So we're going to start with, for the review, is just kind of all the unit circle stuff we've already done, right? How do you find a cosine of an angle or sine of an angle, tangent of an angle, arctangent of an angle, which means find the angle itself, right? That makes this particular value, right? And then down here, if you have you're given a coordinate, go ahead and find all 6 trigonometric values. Find sine, cosine, tangent, cosecant, secant, cotangent, right? So we've done this all before. It's just, bring it back up. It might be handy to have your unit circle around, just in case you've forgotten a few things. Get a little bit, fluency back. That now we haven't done that for a while. But always go back to the 30, 60, 90, which says, if this side is x, and usually we use 1, right, as the x. So the hypotenuse is twice as long, or 2, right? So if the short leg is 1, hypotenuse is twice as big, and the long leg is root 3 times 1, which is just root 3. So it goes from the short leg to the longer leg, right, to the longest side, which is, of course, hypotenuse. And then we have the same thing for the 45, 45, 90. If the rise and the run were equal, both 1, turns out the hypotenuse is just 1 times root 2, or in this case, just root 2. Right. And if each side was 2, right, then this would be 2 root 2. So you just put the length of the leg in front of root 2, and that gives you the hypotenuse, right? So that was very convenient, right? No matter what the legs were, they had to be identical. No matter what it was, put a root 2 after it, you have the length of hypotenuse. Or you could do it the long way. You could go through it. If I didn't know this rule for all these, actually, you could do Pythagorean theorem. So if I didn't know, this shortcut, I could always say, well, what's 2 squared plus 2 squared? That will equal the radius, or r squared, right? This comes out to 8, which is the same as root 8. And then I can simplify this from root 4, root 2, and then finally get root 2. So I can go through all this just to get root 2 root 2, or I can just remember, take the length of the leg and put it in front of root 2, and you'll get the same answer. Okay, but the long way works if you forget it. Just takes a little longer time. Okay. So first of all, let's go over a few of these, and if you already know them, you can just do them, and see if you get them right. See how much you can remember. But cosine of 5 pi over 3. So one of the biggest things we did before is do you remember what quadrant things are in? And that helps a lot. So on this particular one, you could look at this as, well, one way of looking at it is that there's 5 pi over 3s. And this is the same thing. If I put that 5 just kind of in front of it, it tells me I have 5 pi over 3s. And if you remember, pi over 3s are like 60-degree angles, right? Over 3 are 60-degree angles. Well, 5 times 60 is 300 degrees. That's one way of looking at it and helping you remember, where you are at, right? So that 300 degrees would put us, of course, in the 4th quadrant, right? So we got 90, 180, 270, 360. So from 270 to 360 would lie 300-degree angle. Another way of looking at it is that 5 pi over 3 is almost 6 pi over 3. Right? Which is 2 pi. That's almost 2 pi. So you expect it to be all the way around and almost getting back to 2 pi. It's actually pi over 3 short. So one more pi over 3 will get you here, which that will give us the angle, right? So this is the reference angle. This is a 60-degree pi over 3. So what is the cosine, right? What is the cosine? That's what we want to find out. Alright. And pi over 3, of course, is the same as 60. So I always think of 60 and pi over 3 is the same. So we're using this 30, 60, 90 triangle to help us solve this. And if we know the 1, 2, root 3 bit, we can do really well. So we'll have, that'll be a 1, that'll be a 2. Short leg is always 1. Long leg's going to be root 3. Right? And we could find the cosine of that. Right, and get 5 pi over 3 will equal the adjacent over hypotenuse, which equals adjacent would be 1, hypotenuse is 2. And you can always get a calculator and make sure it's in radian mode and put that in there, and it'll give you that answer as well. So these are easy to check, just to remember you know what you're doing. Okay. So yeah, let's just do a few more. Get us to remember this. Give it a quick sketch. What quadrant is 220 degrees in? That's the first question. Where are we at? 3, right? Because we got 90, 180, 270. So that means from one, you want to think of it as 210 as 180 plus 30. That makes this a 30-degree angle right here. So again, we're using our 30, 60, 90 rules, right? With one little difference. And you might recall what it is. Let's see here. What was the most common mistake when these problems were being done? Anybody recall what it is? So what is wrong with what I just did? You got it? Yeah, that's the most common mistake. So we're in quadrant 3, so that's where both sine and cosine, x and y, are both negative. So if you remember that you take care of 90% of your issues that you have with these types of problems. Okay? So mind your signs, right? So if we know that, we can say, well, that's going to equal sine is opposite over hypotenuse. Opposite of this would be -1. Hypotenuse would be +2. So we have an answer of -1 over 2. All right. So that's good. Good reminder. Watch your signs. And then lastly, we have our there we go. Tangent of pi over 2. Yeah, tangent of pi over 2. So we have, now let's sketch this out. Where's pi over 2? What is it as in degree? 90. So 90 degrees would be right here. So remember, tangent though is asking basically what is the slope. They're asking what's the tangent of an angle. They're asking what the slope of that angle is. So what is the slope from here to here? It's undies. Yep, undefined. Yep, so undefined. So, and of course, sine is usually equated with the rise, while cosine is equated with the run, with a unit circle. These aren't unit circles because, you know, we have a radius of 2, but it's a good way of reminding yourself what they represent. So, if cosine is run, sine is rise, tangent is slope, well, it makes sense because slope is rise over run. Rise is sine, run is cosine. That's why sine over cosine equals slope and equals tangent. Right? It's all the same system as rise over run equaling the slope, sine over cosine equaling the tangent. Okay. And then we had some other problems that asked to find, let's just actually go to this one. What is the arctangent of 1? Okay, so think about, again, tangent. You're thinking about what angle. Question here that you want to read this as is what angle makes a line with a slope of 1. Okay? So, yes, you can just punch in a calculator and get the answer, but if you don't know what the question means, you don't know how to interpret the answer, it's good to understand. First of all, when you have arc here, right, that's also the same as arc tangent of 1. What is the yeah, exactly. What angle makes that kind of line? Now, to get a slope of 1, that means the rise and the run have to be the same, right? Only way you get 1 is if rise divided by run equals 1, which means you're getting a situation like this, right? So the rise and the run, 2 and 2, right? That will have a tangent or a slope equal 1, because you get, from 2 over 2. So that's why the tangent will also equal 1. So you want to think about, if you have a slope of 1 or negative 1, you're dealing with 45-degree angles, right? Where the slope and the two legs are the same length, no matter what they are. So with that information, you have to ask yourself, what quadrant are we in, right? That's always the first question, really. So if I'm doing this, what quadrant am I in? There we go. Now with tangent, we had to put, if you recall, when we graph these things, the graphs kind of look like this, those big old things. And it went like this when it went through the origin. It went from negative pi over 2 to positive pi over 2. Okay? Which is important, because when we're dealing with this, you could say, well, right here has a slope of 1, right? That has a slope of 1, no problem. But doesn't this have a slope of 1 down here? So you really get 2 answers, which is problematic. We don't want to have 2 answers for every problem. And we said, you know what, let's just look at only between negative pi over 2 and pi over 2, which would be right here. Negative pi over 2 is here, pi over 2 is right here. Meaning, when we're doing this capital A, or arctangent like this, we don't get answers in this side of over here. We only take the answer in the first and fourth quadrant. And that's why the graph of arctangent looks like this, or tangent looks like this. Okay, so really important to know that, otherwise we'll have 2 answers for everything. So really all we have is a 1 and 1, right? That means we have a 45-degree angle, or we have, or as radians, pi over 4. Okay. But the main thing here is think about slope over here. Okay. And then go down here, and we're just going to find the angle, number 1. Number 2, find all 6 trigonometric functions, sine, cosine, tangent, cosecant, secant, cotangent, of which the latter 3 are just reciprocals of the first 3. So if you have sine, cosine, tangent, do the reciprocal of each one, and you get the other 3. Okay? So first of all, we have negative 2, comma 2. So what quadrant are we in? Always question 1. Negative 2 to the left, up 2. All right. So our angle is actually from here to here, recall. So what angle is that? Of course, that makes this thing a 45-degree angle. So what is our actual theta here? 135, or as radians. So count how many, remember, 45 degrees are pi over 4. So how many 45 degrees did I go? So 1 45, 2 45, 3 45. So that's why it's 3 pi over 4. So pi over 4 is 45 degrees, and we did 3 of them. So 3 pi over 4. That's our actual angle. And then we just do the sine, cosine, and tangent. Of course, we don't have the, hypotenuse here. We do know there's a shortcut, though, so that's where this comes into play. You could go through all this and find out it's 2 root 2, right? Or if you know the shortcut, just use that. So I'm just going to use the shortcut and assume the shortcut. 2 root 2. Okay. Even though that this is negative, when you square it, it becomes positive. So it's the you might recall the hypotenuses are always positive numbers. Okay. All right. So from there, we can just go ahead and write these out. So we're going to do sine 3 pi over 4. So we have, let's see here. It's opposite. So we get 2 over 2 root 2. Which reduces to 1 over root 2 if I cancel out the 2's. Yep. Usually don't want radicals in denominator, so I can just rationalize by multiplying by root 2 over root 2. And we got root 2 over 2. Sometimes written as 1/2 root 2, but most of the time we write it that way. These would be equivalent. So, if I wanted to do the other part of this counterpart would be cosecant. So that would be the hypotenuse over opposite. So we have cosecant. And you can go through all of this and just say what's the hypotenuse and all that. You know, that works just as fine. So hypotenuse would be root 2. 2 root 2, hypotenuse. And the opposite would just be 2. So those just cancel. And you get root 2. You also could have just taken your answer, which is here, 1 over root 2, and then the reciprocal, which I will represent by raising to the negative 1 power. That's the same as flipping the fraction. So, and you also get root 2 that way. So there's a couple ways to go about it. You can just do the whole problem again, or take its counterpart and just take the reciprocal of the answer. You should get the same answer every time. Same thing here. We can go back to and do cosine, which will be very similar. Cosine 3 pi over 4. And we got this time it's negative 2 over 2 root 2. So very similar work, except you have to compare to here, except this was positive. So we got positive, this is negative, so we get negative. So the more patterns you can figure out, the easier this gets, the faster it gets. You might have looked at this, you know, like, well, isn't it just the same thing as this, just with a negative? Yeah, you probably could have skipped all this and just said, it's this answer with a negative in front. That's probably totally fine. So we can do that here with the secant. 3 pi over 4. We can just say, isn't it just this answer right here? Right, and we got to do the reciprocal. Yep, that's all it is. So I could take this answer right here that we got, and just take the reciprocal, and that will equal negative root 2. And no surprise, this was positive root 2. This is negative root 2. All right. Lastly, we'll have let's see here, cotangent. Yes. Opposite over rise over run. You want to think about that? Rise over run or opposite over adjacent. So 2 over negative 2. These are 3 pi 4. You get negative 1. And of course, cotangent would just be the reciprocal of negative 1. Is of course negative 1, right? Pretty straightforward. All right, so we've got short on time, so let me just skip to the last problem real fast, just because it's kind of like this one where we have some undefined and stuff like that, so it's good to recall what this is all about. So this quickly here, just to get it on paper. And we're going to be working on this during Friday in class. So you don't have, you can get started, but you'll have all Friday to finish this. So we have 0, negative 3 down here. So again, we're going to have some undefined stuff. So do we remember what all that is? So our rise is negative 3, right? Our run is 0. Hypotenuse we can say technically is 1 or 3. So Let's write that out. So we have a cosine of course, this is 3 pi over 2. It's going to be 0 over 1. So we have 0. We have our sine of 3 pi over 2 is negative 3 over 1. So we get just negative 3. Our tangent of 3 pi over 2. That's rise over run, so we have negative 3 over 0, so that's undefined. Alright? So let's look at the counterparts for this. So we have secant of 3 pi over 2. And we're just going to reciprocate this, right? So we're going to get 1 over 0, so we get undefined for the secant. And for the cosecant, all right, we're just going to reciprocate this, 3 pi over 2, and get 1 over negative 3. And the cotangent, 3 pi over 2. And take this negative 3 over 0, reciprocal, and that just equals 0. So often if you have a 0 for one of them, when you do its counterpart, it becomes undefined, and vice versa. We got undefined for the tangent. Its cotangent was 0. Okay? And the back side is going to be the assignment, so like I said, if you want to work on that, you can, but our goal is to get it finished by the end of Friday's class. And of course, if you have anything else outstanding, missing, getting that done for all your classes because the quarter ends on Friday.